Hi everybody, hopefully everybody can hear me. Yeah, awesome, that's a good start. I'm getting used to these in-person events again. Thank you very much for coming along to today's talk. I know this is probably one of the last talks of the whole event, so I'm really privileged to be joined by you today. Quick introduction from my part. So my name's Kayne. I lead the data science practice at DataRobot in the UK. I've been with DataRobot about 3 years, but I've been in and around data science for about 10 years. And something I want to touch on today is about the black box debate. I think this is something that we encounter time and time again when speaking to our customers and prospective customers. And I really want to kind of zoom into this debate in a bit more detail. I'm not here today to tell you about the right and the wrong ways to do things, but hopefully I'll be able to seed some ideas about what do we mean by explainability, what do we mean by transparency, and how can we fuel this conversation between the data science camp and the business camp to be a lot more harmonious. So I really have 3 objectives to try and accomplish today, 3 things I'd love for you folks to all take away. So the first thing is that all models can be explained. So some folks think that even the most complex models in the world cannot be explained. I'm here today to tell you that that's not true. And I'm going to give you some ideas on how we can explain some of those more complex models. The second thing is that I think people tend to get sucked into just thinking about models when we talk about explainability. But actually we're here to talk about the wider picture. And lastly, hopefully this is obvious to most folks, but this is one of those conversations that unless you can hold your own and convince your business stakeholders about what your model is doing, it is very unlikely that that model is going to be employed in production and generate business value. So why is the intelligence revolution so important? So I'm sure everybody picks up a newspaper or reads BBC News. There isn't a day that goes past that we're reading stories about the impact of AI on our lives. And really, the closest example of this revolution that we're going through now is the one we've just been through with the digital natives, such as Facebook, such as Google, etc., who have kind of replaced long-standing blue-chip companies from the S&P 500. And every person, every company, every country is going to be impacted by AI, and it's going to dwarf anything that we've seen in the past life. In probably 5 to 10 years, just to be a bit realistic, I think by saying you're using AI in your business will be like you're building dashboards or you're creating Excel models. I really hope that it's going to be that well adopted in the next decade. And I just want to level set. I mean, there's a lot of hype out there about what AI is, what AI is not. This is our definition of AI. And actually, the first thing I want to make clear is when we talk about AI, we coin it augmented intelligence. Everybody hears artificial intelligence. Artificial intelligence implies that actually it's the drones are going to take over the world. That's not how we see it at all. We're talking about augmenting human decision making, but with better decisions. So that's all about building systems that ordinarily require human intelligence. And machine learning is a subset of that. There are other AI applications over and above machine learning. Things like natural language processing, computer vision, demand forecasting, etc., etc. And machine learning is just one tool. It's one tool in your arsenal, in your toolkit, to employ in various scenarios. And machine learning ultimately is about capturing the data from the past, building models of it to learn the relationships, and use that model to infer what might happen in the future. And that's all we're talking about. Now, of course, everyone knows the size of the prize is huge. Whether you're talking about millions, billions, trillions, there's always new articles coming out every single year about how this could actually be transformative in your industry. And there's a really nice study, actually, that we want to present today around actually the adoption of AI. AI adoption, what we've seen, has massively accelerated just in the last 2 to 3 years, primarily due to business models being turned over because of the COVID pandemic. And McKinsey have done some work to show that actually nowadays 78% of organizations claim to have AI embedded in at least one business unit. So we're already starting to get there. And in fact, 22% of respondents are actually claiming over 5% of their revenue to be attributed to AI. And that's huge. We weren't talking about value being driven by AI maybe 5 to 10 years ago. but absolutely now it's about impacting the bottom line. It's having more strategic conversations at the board level and being able to influence that downwards. However, that being said, that is still in stark contrast to some things that we're seeing out there. There are 30% of organizations in this study that still claim to have zero value delivered from it. And that's because, and we're seeing this in practice, we're still seeing R&D units, these kind of innovation hubs that are really still struggling to get things into production. They're selling the proof of values into the business. They're saying what the value could potentially be, but they have not yet productionized it. They have not yet integrated it. They have not yet done that change management, because AI projects are not easy, unsurprisingly. But those that are able to embed AI in their business, as history has shown time and time again with all of these emerging technologies, whether you're talking about steam, electricity, whether you're talking about more recently digitization, AI is just going to be another one of those technologies that the early people are going to outperform those laggards. And again, in the same study, we were seeing that actually it's about 3 to 4x in terms of the improvement. So why are we seeing some organizations being successful and some others not being successful? When we looked into this in a bit more detail, we realized that those high-performing categories, those customers that are really successful with AI, are finding that there's a clear set of best practices that they're embedding into their analytics machine learning lifecycle. I don't want to read through all of these today, but I'm sure there's points on there that will resonate with most people in the room. And of course, you won't be surprised, but I'm going to zoom into this one today. I'd love to spend an hour talking about every single one of them, but I really want to zoom in today into the black box debate. And what do we actually mean by black box? Well, people think about the black box debate being centered around using models to make decisions in a business, but having no understanding of how those decisions have actually come about. So we put data in, a decision comes out, but actually what happens in the middle is a complete mystery. And we want to kind of unopen that black box. And what's actually really interesting for me is that I go down the pub and speak with loads of my friends about our jobs, right? I find myself fortunate to have a job that's quite interesting. This is the sort of stuff that people are talking about, regardless of if they're in data science or not. Everyone recognizes the societal implications of deploying things that can't be trusted or you don't understand. So for me, that's quite an interesting thing. So why does it even matter? So these are some pillars that we see when we talk about transparency, explainability, black box. So firstly, in order to get trust in your model, you can't just give a data set to a data scientist and expect them to build a model that's going to be perfect for the business. You have to, shockingly, be able to bring in that business knowledge, bring in that subject matter expertise, and make sure that's leveraged as part of the model building process. It's an iterative cycle, and unless you get that, you're never going to get that buy-in from the business. The second one, compliance. So some of our most prolific sectors for DataRobot are those where they're highly regulated, because we offer incredible amounts of insight and automated documentation when it comes to model governance and compliance. Value. So again, this comes back to my point earlier about the R&D projects. I think we're starting to see a change where maybe 5 to 10 years ago, these kind of data science center of excellences were being spawned up, and they had a mandate just to innovate. I think that's now changing to actually being, let's drive value. I think the execs are starting to wake up and realize, hey, I've pumped a lot of money into this. I need to start seeing some results. So of course your models need to be deployed in a responsible way, integrated with systems, whether that be databases, RPA technologies, BI technologies, and actually drive decision making, whether that's call center agents, whether that's marketing campaigns, it can be whatever, but it needs to be starting to drive value. And the last one about productivity. So being able to iterate quickly is a common key requirement that customers come to us for. So being able to spend more time on just quickly iterating frees individuals up to start having more business-fueled conversations. It allows them to actually action the model output as to actually building the model itself. And the black box debate, like I said earlier, frequently centers around models and algorithmic choice. And we think of things like linear regression up in the top left there as a typical benchmark for explainability. And as algorithms tend to get more complex, we typically think there's an accuracy gain from that. That's not always the case, but that usually comes at the cost of explainability, or so people think. Of course, things like, this isn't strictly true, this is quite a naive illustration, but things like accuracy doesn't always improve when you put neural nets into the mix. It can actually get worse, but this is quite a simple illustration. So what happens when we can make these types of models increasingly explainable? It means the business are going to be more propense to be able to adopt them into the business. It means that the decisions that you're fueling are going to be more accurate, and ultimately it's going to drive your KPIs to be even more better. But I challenge you, is something really explainable just because it has an equation? I think people say things like this, oh, that's easy to understand. But I'd argue something like this could be absolute hell if you don't understand what all of those features actually are. If they've been derived in a really hard way and are very unexplainable, you haven't got a data dictionary to back it up, that could be very, very cryptic and you have no understanding of how that's been derived. On the other hand, is this really unexplainable? It's a typical neural network, only a few variables in there, admittedly, but actually this can be quite simple to understand if you go through layer by layer. So I think there's this kind of misconception that some algorithms are better than others when it comes to explainability. So let's start looking for methods to be able to look at this through a model agnostic view. And the reason I highlight that is because there are already insights out there at a model specific level. Things like decision trees, anyone can look at a decision tree and understand kind of, I don't know, the relative classification in different kind of parts of your decision tree. The same is true for model coefficients, whether that be a linear regression, logistic regression. It might even be like a genetic algorithm where you've got non-linear terms in your equation. And you've got lots of examples. But the problem with this is you can't compare those insights against one another. How can you compare the coefficients of a linear regression against a decision tree? It's really hard to compare that. So what we're looking for are approaches that look at explainability that have to go beyond the algorithm. And pretty much all the techniques that I'm going to discuss today all follow the same basic principle. By trying lots of different inputs and recording the outputs. So a good example of this is, say you're buying a house, you're going to go around that house and you don't know what your light switches are going to do. Are you going to rip open the walls and have a look at all the wiring? No, of course not. You're going to try some switches on and you're going to see what lights turn on. And that's exactly what we're going to be talking about today. And the very fundamental principle about machine learning is that we're observing a bunch of observations and using empirical evidence to actually see what the output should be. So why can't we use the same approaches for our model explainability? And I think, again, if you think about some of the geniuses throughout history, right, they've managed to kind of reduce the very complex universe down to a few equations. But actually, the majority of human kind of knowledge has been gained by just trying stuff out. And that's what we're going to be talking about today. So some of those model agnostic views, some of these technologies or tools might be familiar with you, and I want to step through a few of these in turn. So things like feature impact, you can use Shapley or Permutation Importance. I'll go through both of those. Feature effects, this is ultimately partial dependence plots, very, very powerful. You can also look at things like surrogate decision trees. So even for things like a neural network, you can actually fit a surrogate decision tree on it so that you can compare it against a decision tree. Quite cool mathematics behind that. And then at a local level, being able to actually individually explain every prediction, you can do this through various tools as well. So SHAP is a very commonly known one, Lime is a very commonly known one, and I also want to touch on a DataRobot patented one called Zemp as well. So let's jump into some of these. So permutation importance, this is really probably one of the first ones you'll engage a business stakeholder about. One of the first questions they will challenge you to answer is, what is the important attribute in my model? What are the important attributes of my model? And this is what permutation importance is all about trying to answer. This is often called drivers or drivers analysis. You might have seen a lot of that out in industry. And this can offer significant value to an organization without actually having even deployed the model. So the way this is calculated, permutation importance, it's effectively by taking each variable in your data set. Let's say you've got 10 variables, take each of those 10 in turn, you permutate them, randomize the values in that column, you take your trained model and recompute your predictions, and you see how much those predictions have deviated versus what they were originally. Ultimately, you're using it as a proxy to understand how much more worse is your model by having randomized those values. And if your model is super sensitive to that variable, it means that your accuracy is going to have changed quite significantly, and of course the inverse. It's a very, very powerful way for business stakeholders just to understand at a high level what's important. I used to work at British Airways many moons ago, and we built some of this analysis to understand what drives Net Promoter Score. We've got the full kind of end-to-end journey from a customer going through British Airways, and they wanted to understand, is it the baggage, is it the arrival experience, is it my seat, is it the food and drink? They have all of these various parts of the proposition that they could pump money into improving, but they wanted to understand, where am I going to pump money in that will give me my biggest bang for my buck? So by doing a piece of drivers analysis like this, without even deploying the model, we built something called the investment appraisal tool that sits on top of it, that allows finance teams to then evaluate actually what's going to be the return of investment if they pump £1 million into different parts of the proposition. So really interesting piece of work, and you'll see this time and time again across industry. Second one I want to touch on is partial dependence plots. I have to say this is probably my favorite. I think that's quite geeky admitting that, but I will anyway. This is another tool that in itself can drive huge amounts of business value. And this is without, again, having to actually deploy the model. So these tools effectively are isolating the relationship between a feature and the thing that you're trying to predict, so your target variable. But this is not quite simply plotting one variable against another. This isn't BI. This is taking your model and saying, by holding all other things equal in my model, what is the pure relationship between that feature and the variable? So it adjusts for any covariation you might have between your variables and gives you that true relationship. And again, I've seen this work very well across sector for various use cases. The one I particularly like is when speaking to retailers or banks around price elasticity. Everybody knows that demand is a function of price. People can rarely isolate what that true relationship is. So being able to build price optimization models, because you'll have a U-bend in your price partial dependence plot, understanding that point and optimizing that is going to maximize your revenue. And again, that's something that can go across sector. Shapley Values. I'm sure everybody knows who Lloyd Shapley is. Very profound mathematician, one of the founders of game theory. I studied OI, particularly love this guy. But these are one of those tools that you can look at from a global or a local level. What you're seeing here is actually being able to explain predictions at an individual prediction level, but you can do this at a macro level too. And effectively, when one computes the relative importance of a variable, as per the previous slide, you have to account for the covariation between other variables. So what the Shapley value does is it looks at the immediate kind of direct relationship between that feature and your target, just looks at the correlation, but it also looks at the covariation between that feature and all of the other features and their associated knock-on impact onto the target variable. So often when you look at correlation, it gives a kind of an underrepresentation of the true value of that. So we have a calculation that allows you to assess this kind of direct and indirect impact on your target variable, and that's the Shapley value. And effectively what you're doing, we're going to get deep into the mathematics a little bit, you're effectively building models and looking at the differences in R² or some other model fit statistic from adding this variable in versus not having it in. But this is modeled across all subsets of variables, across all numbers of different variables. And the best analogy I can think of is about sports teams. So imagine a football team, imagine a basketball team, and if you wanted to understand the relative importance or value of a player, what you would do is probably play some games with and without that player. But it gets far more complex than that because you've got to look at every single combination of numbers of players and also the players themselves. So this gets very big very quickly. Even with a model with 20 variables, you're looking at 1 million different models that need to be trained. So this is very computationally quite intense, even on a modern desktop computer. And that's why DataRobot, about 6 years ago, went about trying to build something that was comparative, but could run in a much quicker time. And this is what we call XEMP, stands for Exemplar-Based Predictions. And this is designed to really simulate what Shap's doing. The interpretation of it is slightly different. Unlike Shap, it's not additive. So Shap, you can kind of add up all the contributions. Can't do that here. So you have to be a bit more careful. But it's very powerful, not just at the point of training, but also at the point of inference, of being able to explain why a particular prediction was made. So what you're seeing on that graphic there are, if you take the top row, it's a very high prediction. I can't remember exactly what the number is, but then left to right, you'd read that top row as the first one has the highest positive contribution on that variable, on that prediction being as high as it is. Then going down in ascending order, left to right. And the same for the bottom row. Why is that prediction as low as it is? Again, gives you the individual reasons. And again, taking you back to kind of my old days, I used to do some kind of call center, cross-sell, upsell type work. We're putting these kind of model scores into the hands of call center agents and ask them to hold a conversation. Well, that's very hard to do. However, if you contextualize those predictions with why you're cross-selling a particular route, product, etc., that actually allows them to have a far more human conversation. And we saw when we did an A/B test, significant improvement by just adding these prediction explanations in. And what do we actually really mean by explainability? Like I said earlier, some of you might be thinking, yeah, well, that's great, Kayne. You can tell me how to explain what my variables are doing in my model, but my stakeholders still ask me what's going in my model. I'd still take you back to that light bulb analogy. Right? And question, is that really that important? For me, one of the more important things is to actually understand, like, are you comparing to a good benchmark? A lot of times black box is compared and criticized versus kind of human decision making. But actually challenge you to think, is human decision making really that objective? Do we know that if we give the same inputs, we'll always get the same outputs? I don't think that's strictly true. And I think black box models get a bit of a bashing, but we need to step back and think, actually, if human kind of rationalization is our benchmark, then we've got quite a way to go. So instead, I'd be pivoting the conversation around black box models to be more about black box processes. I think as data scientists, we're at risk of being too focused on the algorithm. You can explain what an XGBoost model is. You can explain what any model does, but actually you should be pivoting that conversation. If you can surface how predictions are generated, what's actually explaining those predictions in a data-driven way, the only other thing to really challenge yourself about is this data accurate? So actually being able to look right through that life cycle and not just absolving yourselves because you think that it might not be part of data science. And I know this might be a bit of a controversial subject given what we've been through in the last few years, but I wanted to use this as a way to back up my last point here. Think how many lives were saved due to the vaccine. I'm not talking just about COVID vaccine. This is an example of smallpox over a couple of hundred years. They didn't actually understand what a virus was until they were actually giving people these vaccines. So again, it comes back to empirical evidence gathering. The human body has been a black box for millennia, and therefore it hasn't stopped us from making incredible advancements in medical technology, amongst other things. So I think I'm perfectly on time. So just to wrap up, hopefully you took away some points there. First one is there are numerical methods out there that allow you to assess every single model, whether it's a simple logistic regression, whether it's a really complex neural network. Secondly, that actually we need to be thinking a bit more big picture when we talk about explainability, when we talk about trust, when we talk about ethics. We need to be thinking about the model, but we need to be thinking about the raw data as well as the decision making at the end. And the last one, hopefully this took this away, is being able to get your business stakeholders on board, engaging them in the conversation is the only way to allow you to be successful on delivering your AI projects. Thank you so much for your time, and encourage any questions.